React, being a user interface library, has been doing its job quite well over a decade. The component architecture, unidirectional data flow, and the declarative nature of the library have stood out in building production-ready and scalable software applications. Over the releases, even till the stable release of React 18.x, React has provided various technologies and methodologies for creating performant and optimized application. To name a few, the entire memoization paradigm using react.memo higher order components or use memo, use callback hooks are there for creating optimized solutions. If you are new to the word memoizations, it means in software programming, it's a technique for optimizing your program so that your program executes faster by caching the result of expensive computations. Though React memoization techniques are great and it is there to optimize your application, but remember once Uncle Ben said, with great power comes great responsibility. So we developers need to be a little more responsible in terms of using those techniques in our application and in our source code. Optimization is great, but over optimization is really a killer. With React 19, the things are going to change. React has announced a release candidate as of making this video, where there are plenty of features that got included for the React developer community to boast about. Very recently, I got a chance to moderate a panel discussion in a conference called React Nexus, and that is where we had two awesome engineers from Meta. One was Naman Goel, who was from the StyleX team, and another was Satya Gunasekaran from Meta, especially from the React compiler team. While moderating that particular panel discussion, I got an opportunity to learn and getting more curious about one thing is called React compiler. So along with all the features that React 19 is getting, or React 19 already proposes for developers to start experiment out, React compiler is the one to look out for. Apart from React compiler, there are other features in React 19 like React server components, the server actions, the easier and organic way to handle document metadata, enhance hooks and APIs. I have created a video where I have explained that how React 19 features are going to change you and the way that you code and think with React. Please look out for that. The link is in the description of this video. The introduction of React compiler with React 19 is said to be a game changer. From now on, you can give all the optimization headache to the React compiler than you take it as a React developer. Does it mean that we don't have to use react.memo, use memo, use callback, all these things all together once we start coding with React 19? The answer is mostly yes. The compiler would take care of all these optimizations automatically as long as you adhere to the rules of React while developing a component or a hook. But how? Yes, that's where this video comes handy. We are going to get deep down in understanding React compiler, its architecture, how it works, build application around it, and we'll appreciate the fact that React compiler is going to come to our life and going to enhance it for our development process. But before that, let us understand what exactly a compiler is at a high level. To simply put, a compiler is a program or a tool that translates any high-level programming language code or the source code into the machine-level code. But this is not a one-step process. There are multiple steps involved to translate a source code into the machine level code, and compiler has to go through all these steps. Let's understand them at a high level. As you are seeing in the screen, the input is the high level programming language, and there are multiple steps through which this particular source code has to go to finally result out something that machine understands. The first step is the lexical analysis, where a lexical analyzer tokenizes the source code and generates something called tokens. So it means that if you write something like, say, function ABCD, and after that a parenthesis, then inside the function you write a lot of lines of code, it is here that your lines of code will be broken and the individual tokens will be created. After this step, the syntax analyzer comes into picture and it creates an abstract syntax tree. It is also known as AST to structure the source code token logically. Then this is passed to semantic analyzer, which validates the semantics or the syntactic correctness of your code. This is where you will be seeing error if your code is having any kind of syntactical error. After all these three type of analysis by the respective analyzers, an intermediate code gets generated. It is also known as IR code. If you go deeper into understanding how compiler works, you will be definitely encounter the term called IR code. Finally, there are some optimizations that put into on the IR code, and then the code generation happen as a final step, and then you get a translated code that machine understands. So as we understand the compiler now, let us look into React compiler and its architecture, that how different it is from a regular compiler and its steps, and what exactly it does extra in terms of optimizing a React application. React Compiler is a built-in tool that you need to configure with your React project using the ecosystem given by your React tool systems. For example, if you're using Vite to create your React project, there is a way to add the configurations for React Compiler to enable the compiler for your React 19 project. If you use Next.js or Remix or anything else, there are different configurations available. In this video, we'll be building an application using React 19 under the Vite configuration or the Vite ecosystem. There we'll see how to bring React compiler with React 19 to understand how the compiler works. But before that, let us get into the architecture a little bit more deeper. React compiler has three primary components. One is the Babel plugin. It helps transform the code during the compilation process. We'll get to that in details. Then the ESLint plugin, it helps in catching and reporting any kind of violations of the rules of React. And then the third is the compilation core code, where the code logic resides that performs the code analysis and all kind of optimizations. Both Babel plugin and the ESLint plugin uses the code compiler logic in the compilation process. Now let's check out the compilation flow. The compilation flow goes like this. The Babel plugin identifies which functions, which are nothing but components or hooks in React, to compile. We will see some configurations later to learn how to opt in and opt out from this compilation process. The plugin calls the core compiler logic for each of these components and the hooks, and finally create something called an abstract syntax tree or AST. Then the core compiler converts this Babel AST into IR code. We had a mention of IR code when we discussed about the compilation steps generically before. Then it analyzes, validate, and run various kind of validations and passes to ensure that none of the rules of React are broken. Next, it tries further to reduce the amount of code to be optimized by performing various kind of passes to eliminate any kind of date code if you have it in your source code. Then the code further get optimized by applying memoizations on top of it. Finally, the optimized code, which is a transform AST from here to here, gets converted back to an optimized JavaScript code or optimized function, which is started with an unoptimized thing, and now we get an optimized component or optimized hooks. The steps we have seen just now, it's at a very high level. If you want to get into deeper on each of these steps and want to understand what exactly happening, I have shared a link from the React compiler working group discussions where they have explained the journey, the architecture in much more detail. You can take a look. The link is in the description of this video. We have used the phrase rules of React multiple times so far in this video, but what are those rules? If you are a React developer, I'm sure that you are managing and maintaining those rules in your code or the code you have been reviewing. But if you're new to it, let us see those at a very high level, and you have the React documentation anyways to jump into it and learn them much deeply. The React components, the React function, React hooks must be a pure function. It means that React components are assumed to always return the same output with respect to their input. As long as you are providing the same input, you are going to get the same output for that input. That is the expectation. Side effects must be running outside of render. Props and states should not be mutable. It means that you should not change props and states directly. Return values and arguments to hooks again should be immutable. You should not change them directly. Values are immutable after being passed to JSX. That is another rule. Then there are few other rules about calling. Never call a component function directly. That means that though your components are functions, you should not be calling them as you call functions in JavaScript. Rather, use them as your JSX, like the tag that we see. Never pass around hooks as regular values. Hooks should only be called inside a React component. Outside of React component, like in your utility functions or elsewhere, you cannot call the React hooks. Then there are few rules for hooks as well. The hooks can only be called at the top level. You cannot call them inside loops, inside any kind of conditions or nested functions. Instead, always use hooks at the top level of your React function before any early returns. And only call hooks from React function. Don't call hooks from the regular JavaScript functions. So these are the rules, and the React compiler will look into each of these rules and their violations using the ESLint plugin we mentioned before. As we understand the philosophy and the architecture of React compiler, let us see React compiler in action. And for that, we'll be looking into the code and build something along with React compiler and React 19. On your screen, you are seeing an application that is something like a product page. What we show over here, we show total number of food products with a heading called the food product over here. And then below that, there is a product list where I have 4 products listed over here. You can see them. And then there is a list of featured products. There's a featured list. And among all these products, we have featured 2 of them. So it means if I take this entire product page as a component, inside this, there are 3 other child components. It means that we have a food products as a child component. Then I have a product list as another child component. And there is a featured products as another child component, and assume that this product page main parent component gets the list of products, which is hamburger, french fries, taco, hot dog, and what we need to show as a heading, the food products, as a props from outside. We are going to see in the code very soon. But before that, there is an explanation that I want to give. In React, generally, when you have the component hierarchy, it means you have a parent component and inside that there is a child component. If the parent component re-renders, the child component also gets re-rendered. In our case, the component architecture of the hierarchy is like this. There is a product page which gets products and heading as the props, and then it passes the heading to the heading component. You can see this. And it also computes the total number of products that we are passing, the number of it, the length of the products array to this heading component. So these 2 props get passed to the heading components. Then the products alone as a props get passed to the product list component. And we also compute featured products out of this and then pass that to the featured products component. Now, in this case, let's say the heading value changes. If the heading value changes, the props changes, that means this particular product page is going to re-render. Of course, because it has to show the latest heading. Now, as this parent component gets re-rendered, what will happen? All the child components will be re-rendered. That's how React traditionally works. But if you see, only the heading component that got changed over here, and the heading component is getting passed only to this particular child component. It is not at all getting passed to product list and the featured products. Then you would ask why the product list and featured products we are re-rendering unnecessarily, because this is not at all related to the props that's originally got changed. That is where the optimization come into picture. One of the way you would optimize this is by putting the memoization technique. You can do react.memo on the product list and say that until unless the products changes, I'm not going to re-render this product list. You also can apply use memo on the feature products computation, that until unless feature products is having a new value, I'm not going to do the feature products re-rendering. So these are the things as a developer you need to take care, you need to control. That's what we were talking about, that memoization is a great technique given by React, but there is lots that as a developer that you need to do. But with React 19 and the React compiler, we are going to change that paradigm. So with that paradigm shift, you don't have to use memo, react.memo, use callback, any other optimization technique. Rather, React compiler going to do that automatically. That is what we're going to see through code now. What you're seeing on your screen is a React application I have created using Vite. There is no React compiler or anything related to React compiler I have done so far on this project. Only thing that I want to mention over here, that the project is created using React 19 RC release. Now coming to the app.js file, I see that I have created an array called food products, which is having a bunch of product with its ID, name, product image, and whether the product should be featured or not, that particular Boolean value indications. And after that, I have a component called product page, the one that I was showing you from the screen, where I am passing all the products and also the heading value. Let us go inside the product page. As I come inside the product page, I see that there are three components I have imported over here. One is the heading, another is the feature product, another is the product list, which we have seen from that image a while back. Now, these three components I am rendering over here. First the heading, then the product list, and then the feature products. If you see, the heading is taking the heading and the total number of products, which is nothing but the products.length, right? This is what I am computing. The product list is taking the products that is getting passed as a props. I'm directly passing it to the product list. And the feature products is also taking something called the feature products, which is computed from this particular products using the JavaScript arrays filter method. Very simple component that we have. This heading is another simple component which takes the heading and the total products and show it in the H1. The product list gets the products as a props, iterate them through using map and show as a ULLI. Similarly, the feature products is also get this as a props, and again with ULLI it just renders the feature products. Very, very simple. Now with this hierarchy, what we just explained, that if the headings changed, this particular props change from the app.js file, this is only supposed to change the heading. Because these props I am not passing to product list, I am not passing to feature products at all, then why I am going to re-render this? Is React really re-rendering it? Yes, it is doing. Let's see that in action. Coming to the heading component, just beside the heading, let me add a timestamp using date.now. This is going to give me the timestamp. The similar thing I'm going to do with the product list page. I'm adding this date.now over here, and also I'm doing the same thing in the feature products. So now if I go to the UI, do you see that I have a timestamp beside the heading in each of this component? Now what I'll be doing, I'll be changing this particular the food products to something else. That means the props that I am passing to the product page, I'm going to change this heading props. And I'll see the timestamp for each of these things are going to change. Here it is 71, here it is 67, here it is 75. Ending with, it will be a completely new value. Just take a note of it. So let me go to the code. Let me go to app.js file. Now coming to the app.js file, this particular heading, the food products, let me just remove this S from here and make it like the food product. If I come back to the UI, do you see each of these things got changed now? They have a new timestamp, not only for the heading alone, but it has changed for the product list, it has changed for the feature list as well. So it is changing, it is re-rendering each of this component, even though a particular props which is being used in only one of the child component, rest of the child component is also getting re-rendered. Now this problem can be fixed using react.memo, use callback. How? You will be able to do something like this. For example, this product list, you can put behind the react.memo and say that until unless the product list is changing, I don't want to re-render this component. Or this particular computation of get featured where we are doing the filtering, you can put it inside and use memo and say that, hey, I am applying a memoizations over here until unless the products change, I don't have any reason to compute it. So in that case, even though the headings change, you are not going to get a new recomputed feature products. You are also not going to get a new product list component re-render. So this is how, using the memoizations technique in React, we can do this and we can solve this problem. But we are talking about React compiler, isn't it? So let's do and let's learn how to do it in the React compiler way. If you're enjoying my teaching and my content, don't forget to subscribe to tapaScript because it gives me a lot of motivation to create good stuff for you. Configuring React compiler with React 19 is a multi-step process. As we have created a brand new application using React 19, we will first check whether our application and the components inside it are compatible enough to get React compiler into picture. After that, we'll be installing the ESLint and the Babel plugin. Then we'll be doing some configuration for ESLint and the Babel, and that's it. We will then rerun the same application and see what kind of optimization React compiler is giving to us. React compiler, we know that as an opt-in build time tool. It doesn't come bundled with React 19 as such. So prior configuring the compiler, I can do a health check of my code base whether the compiler is compatible or not. For that, I'll be using this command npx react-compiler-health check at experimental, because React compiler itself is experimental now. And I'll say run this command. Do yes. So this will check and report me on three things. How many components can be optimized? is saying that I have 5 components, all 5 components can be optimized. If the rule of Reacts are followed, for example, it found the strict mode and all other stuff and no usage of incompatible libraries. So it means I can now freely go ahead and start integrating other pieces of React compiler. The next thing is about installing the ESLint plugin for React compiler. I'm using Yarn and doing yarn add this particular plugin name. You can also do with npm, pnpm, bun, whatever you would like to. So let's install this. Installation is going on and it is done. Now we have to go to ESLint configuration. For that, as I'm using Vite, I have this ESLint RC file. I'll open this up. I'll search for the configuration option called plugins. Over here, I'll be adding the plugin related to the React compiler ESLint. So ESLint plugin React compiler, I have added this. And then I'll be searching for rules. And along with all the existing rules, I will also add rule for React compiler that it is going to throw error. So that's all for the ESLint configuration. Finally, I have to install the Babel plugin. For that, I'm doing again yarn add babel-plugin-react-compiler experimental. Let's install this. Installation is in progress and the installation done. Then approaching the last step, open up v.config.js file, and over here you already have a default config. You are already importing React. Now let's create a React compiler config. We will keep it empty for now. For any kind of advanced configuration where you have to provide any custom runtime module or any other kind of configurations, that's what will go inside this. For us, we'll keep it empty. Then coming to this define config, you have this plugins, you have this React. Over here, create the Babel configuration. So Babel : then plugins. This is of course an array. Inside that, let us put the Babel plugin React compiler along with the configurations that we have defined. The same configuration is available in react.dev as well. And as we are using Vite, we have provided this configuration into the vite.config.js file. If you are integrating React compiler with Next Remix, for them also the configuration is there in the doc, and the link of the doc is in the description of this video. So that's it about the configuration. We don't have to do really anything else. Let's go back to the application. So now it's time to see the behavior of the optimized app. Same code where the child components were re-rendering for the re-rendering of the parent component. Now the same code with React compiler configuration along with it. Let's see how it behaves. I have the code and the UI for it running side by side. You are seeing this timestamp again over here. Just notice that this one is ending with 25, 25 and 29. In the app.js where we have this product page and this heading, I am going to add and change this heading saying that the food product to the food products. What happened at the right side? The S got added, the food products, but the timestamp didn't change. The timestamp for this is constant, the timestamp for this is constant, the timestamp for this is constant. Let me add few more things. 3232 I have added. Even in this case, I'm seeing this, the timestamp are not getting changed. So it means the re-rendering of each of this child component or in its fullest is really not taking place. The product list and feature list is not re-rendering at all. The heading component is re-rendering, but only the place where the change is supposed to happen, only that particular place is changing. So it is optimized to that extent that even though this particular component is re-rendering to reflect the latest changes of this heading message, still the other part of the component is not refreshing or re-rendering. So optimization is in place. Isn't it awesome? This is what we have seen. If you go to vite.config.js file and then this particular configuration you just take away, after that you come to app.js file and then start changing these things back. See, things started changing again because now I have taken out the React compiler's capability from my application. So this is one way you can opt in or opt out globally for your entire application for React compiler or not. If you have the configuration back, you have enabled it. If you remove this configuration from here, for the entire application, you have removed it. Let us see another awesome thing. If you go to React Developer Tool and if you have the React Developer Tool version 5 or higher installed, you can now see a badge called memo with this particular emoji to tell you that this particular component is already optimized by React compiler. So I see this beside app, product page, heading, product list, everywhere, this particular memo badge. If I go to code now and just like before, if I just remove this guy, so right now I don't have the React compiler anymore. Now if I come back, you see there is no badge provided over here because right now the React compiler is not there, so nobody is really optimizing things. So this is another great thing that got added in the React DevTools to support the React compiler in React 19 application. Whatever we have seen so far, everything seems to be really great. But let's get into the internal of it. How is it really happening? How this compiler is optimizing it? Okay, we know the flow, we know how the steps, all kind of optimizations are happening. But let's try to see in the code like how it works. I am showing the React compiler playground. The left side of it is our heading component. We have seen this in the Visual Studio Code editor where the heading and the total products were getting passed as props, and the heading and total products we were showing over here. And to show the re-rendering is happening or not, we had added one date.now, if you remember that. And then regular JSX was returning from this particular component. Now on the right side, you are seeing the generated code. Now we'll be going through this generated code and try to understand for a component like this, how this code is functioning. How this code is taking care of optimization, taking care of caching, memoizations, and all these factors. And if you understand this concept well, you can put any component in this compiler playground at the left side and try to see like what kind of code is being generated at the right side, and you can learn far better. The link to the React compiler playground is in the description of this video already. Let's get into it. During the compilation process, the React compiler is going to translate the code that you are writing and refactor this particular code using a special hook called _C. This _C hook was previously known as use memo cache. You can search for use memo cache and learn the history about it. What it does, it basically create the array of cacheable items. Now here it is having an array of 4 elements. Why so? Because you have two props over here. One is heading and one is total products. It has to cache that, and only when the value changes, then only it has to think about re-rendering this particular component. So it has to cache these two. Then the third one would be the JSX itself. Unless otherwise this heading and the total products changes, these dependencies are changing, there is no need of recomputing this particular JSX. So this is another cacheable items. And apart from the heading and total products, which are the explicit dependencies to the heading component, there is one more variable factor over here. That variable factor is the date.now. If date.now changes, then the dynamics of this entire JSX changes. That means it will be new JSX, new re-rendering is required. But until otherwise date.now is changing, or it is changing from inside or outside, you no need to do this change. So there are 4 things that are cacheable items over here. One is heading, total products, date.now, and the JSX itself. That's the reason _C is instantiated with 4 elements. Now from this T0, we are destructuring heading and total products, which is like heading and total products, our props. While instantiating each of these with the 4 elements, this $, $0, $1, $2, $3 will be initialized with this symbol dot for react.memo _ cache.sentinel. It is just getting initialized with it. It is not storing anything else beyond this in the beginning. All right. Now let's proceed. Now it will create the memoization block. Memoization blocks are usually creates using if. Here you will see 2 if. One is over here. We'll go through it, and then another if which is over here. Now for memoizations, it has to keep value into variables. So for each of this memoization block, for each of this if statement, you see there is a variable. Let T1 got created, here let T2 got created. We will tell like what is the importance of this T1 and T2. Let's see one by one. First if block is for the date.now. What is happening over here? It's checking if it is first time, right? If the $0 is having this particular symbol, because I told that when the initialization happen, each of the dollar value $0, 1, 2, 3 will be initialized with this particular symbol. Now, if it is the case, that means it's the first time. If it is the first time, this T1 variable is being used now, and this will be assigned to the value of date.now, because this is what it's over here. And this particular value now will be assigned to $0. So next time, think about it. Until unless there is a reason that date.now has been changed, or there is a reason that $0 is having any other value than the date.now's computed value, this particular block will never ever get executed because $0 now has T1. So next time, next iteration, this particular block is never going to get executed. As this is never going to get executed, T1 will always have the value that we have put into $0, that is the cached value. So in this line, we are caching the value, and in the else part, we are always using the cached value. Similar kind of thing over here as well. For the second part of it, it is now checking the heading and total products, which is like the props, whether $1, $2, having the heading value and total products value which is having a change or not. If these are not equal, so it means that the cached value has changed. So what it has to do, it has to compute the JSX once again. So that's what it does, the computed JSX. If you see, we're using this heading, using this total product, and T1 is the new date which was computed before. So T1 is being used over here. Now it got assigned to a new variable called T2, and then heading, total products, and T2 get cached to $1, $2, $3. Now again the same thing. If heading and total products are equal, that means those are not changed. In that particular case, again I am returning back this entire stuff, the entire JSX, which is like T2 from $3 itself, because $3 has cached the T2 over here. T2 is nothing but the computed JSX when the headings or the total products get changed. So this is how it's a normal plain old JavaScript code. This is not our React code. The React code is over here. So for the compilation process, this code is being prepared so that compiler can optimize whatever the ways possible, caching each of the part of the value that are applicable, and return you the updated JSX only when it matters. Now to run through the process again, if I am changing heading, for example, if I'm changing heading, what will happen? The heading will have the latest value of the heading. Now this particular portion $0 of symbol, this date only after first time has never changed. So that's the reason date.now is always becoming static when we enable the React compiler. Now as the heading guy change, so this guy will be getting inside it because this $1 value and the previous heading value won't be equal. So it is not equal, this is satisfying, so it will go inside. As it goes inside, the T2 will be computed with the new heading value, T1 anyway the date that is coming from the variable that we had cached before, and then we have cached again and we have returned a new T2 which will have the latest value of heading. So only heading changed. So it means this is the reason, as the heading was not getting passed to product list and the featured products list, those component, there was no point of re-rendering those particular nodes at all. So I hope you understood. Use your own component on the left side and see like how it translated the right side, and try to go step by step so that you practice and learn it much faster. Now let us discuss about a few side cases. As JavaScript is quite dynamic in nature, there might be possibilities that in certain cases the compiler is not able to optimize or maybe throwing error in terms of compilation or the optimizations of your React component. And you want to opt out a particular component or the hook from the compilation process. We know how to opt out globally for the entire application. That has to be done in the v.config.js file or its equivalent if you're using something else like Next.js or Remix. But if you want to take out a particular component, in that case, you can use certain directive. As it is mentioned over here, if your app doesn't work properly after compilation, and you are not seeing any ESLint errors, the compiler may be incorrectly compiling the code. To confirm this, try to make the issue go away by aggressively opting out of the component. In that case, you can use this use no memo directive in your component. Usage of this particular directive is only for the troubleshooting purpose. This is not something that you will be using to proactively opting out from the React compiler compilation process. Please keep that in mind. There is one more way. In some cases, you might want to configure the compiler to run in the opt-in mode. Okay, using the compilation mode, this particular thing, that you have to give it into the React compiler config object, which we had created in the v.config.js file we have showed, and we kept it empty. So in that case, if you give the value called annotation, the options, and now this makes it so that the compiler will only compile components and the hooks that are annotated with a use memo directive. So first, in the vidconfig.js file or in the equivalent configuration file, inside the React compiler config object, you put compilation mode as annotation, and then whatever the components and hook you want to compiled by the React compiler, going there, just put the directive called use memo. That's it. If you do that, only in that case, only those components and the hooks will be considered for compilation. Rest of it will be opted out and ignored. So these are the things you are good to know, because React compiler itself is in the experimental phase at this point, and it is good to experiment all the things in and around. Now the final question. We know that React compiler is not bundled along with React 19. It's a tool that you should use while building. It's open source. Now it is like a plug and play. So can you use this React compiler with a version which is earlier than React 19, for example with React 18? In the documentation, it is clearly stated that it is always recommended to use React compiler with React 19 only. But in case you want to use it for the earlier version, the React working group discussion is having a thread. I'm just showing that in front of you over here. You can use it, then you have to define your own underscore C function. And in that case, there are certain polyfills available. The polyfill is available over here. This gist you can see, and see how you can opt in for React compiler in a React version which is earlier than 19. If you want to get started with React 19 coding along with React compiler and any other React feature, I have created a template repository called Code in React 19. It has React 19, it has Vite, it has Tailwind CSS, everything there. So you can just click on this particular button called use this template, create your own repository and give a repository name and get started with a fresh repository on GitHub to start coding with React 19, React compiler and all other React 19 features. I hope you like it. Did you find it helpful? If so, let me know by putting a comment below. Also, don't forget to like and share this video, and as usual, I would ask you to subscribe to tapaScript because it provides me enough motivation to create great content for you. I'll be back again with another React 19 video because I have to cover the APIs, the hooks, server actions, all these things introduced in React 19. Can't wait to share my learning with you with a similar fashion, getting into the fundamentals and creating projects along with it. Take a great care of yourself. We'll be back soon.